Alright guys, so today we're going to take a look at section 3.3, solving systems using substitution. So the nice thing here is that you've probably used substitution before back in Algebra 1 when you first talked about systems. So I'm hoping a lot of what we talk about today will be review for you guys. Okay, but before we get to that, as always, we have an opener, so let's go ahead and take a look here. Alright, so George wants to work enough hours to make at least $77 this week. Before taxes are deducted, we're not going to worry about Uncle Sam here. So, first sentence here, kind of a key phrase in there, at least $77. Or another way to think about that is if you want to make at least $77, that means you want to make greater than $77, right? If George made 80, I'm sure he'd be pretty happy with that too. Okay, his job pays $5.25 per hour. Ooh, that's not a good salary, but that does seem like an important number for us. And he's already completed 11 hours of work this week, so that also seems important. If George's work schedule requires him to work in full hour increments, so, in other words, he can't work for 30 minutes, he can't work for 45 minutes, he has to stay full hours. How many more full hours does George need to work in order to meet his goal? Okay, so you could set up an equation, right? But the reason why I pointed out that he wants to make at least $77 is I think an inequality would work better here, right? Because as long as George makes more than $77, I think he'll be pretty happy with that. Okay, so we want more than that. Well, how much has George already made? So he's worked for 11 hours at $5.25 an hour. So that would be $5.25 for 11 hours, right? You work 11 hours, $5.25, you got to multiply, okay? And so the question is asking how many more hours does George need to work? Well, he's still going to make $5.25 an hour, and I don't know how many more hours he wants to work, so I'm going to go ahead and call that X. So now we can go ahead and solve this inequality for X here, right? Because this will tell us how many more hours we need. So go ahead and multiply 525 times 11 is going to be 50. Whoops, that was bad. Let's try that again. That's going to be 57.75 plus 5.25x still has to be greater than 77. Subtract the 57.75 on both sides. Oh, that was not good. Minus 57.75. And that cancels out. So we get 5.25 is going to be greater than 77 minus 57.75 is 19.25. Whoops, forgot the x. That's kind of important. So 5.25 times x means I will divide each side by 5.25. 5.25. So we get x is greater than, and if you do 19.25 divided by 5.25, I believe that's going to be 11 thirds. Now, 11 thirds, not really the best way to have this answer, okay? So let's go with the decimal instead here. So let's get rid of that. And the decimal is something like 3.66666, a whole bunch of sixes after that, so I'm just going to say that it's 3.6 repeating. So x has to be greater than 3.6 repeating. X is the number of hours George still needs to work. So he has to work at least 3.6 hours. So remember here now, George can only work in full hour increments. So 2 hours is not enough. 3 hours is not enough, right? Because I have to go 3.6 repeating. But 4 full hours will get George to $77. Okay? So a little refresher of things we talked about last chapter. Okay? Good. All right. So let's keep going. And let's talk about substitution. Okay? So far this chapter, we've talked about how to solve a system by graphing, right? We take the two equations, we set them equal to y, and then we go ahead and graph them using the slope, y-intercept, and we look for where they cross each other or where they intersect. Okay? Today we're going to talk about substitution. All right? And so when are we going to use substitution? Well, you're going to look at substitution when one of the equations is already solved for our variables x and y. If one of them is already solved for x and y, you can go ahead and substitute that value into the other equation, which is pretty nice. Or if it's pretty easy to isolate one of those variables. Okay, so if it's easy to isolate one of those variables, you can also use substitution in that situation as well. Okay, but again, we're still finding the same thing. We're finding the point of intersection. We're finding where those two lines are going to intersect. Okay, so let's take a look at an example. Top of the next page. How do I use substitution to solve a system of equations? Okay, well, let's take a look at our two equations. 5x minus 2y equals 4. So in our first equation, right, neither variable is solved for here. X has a 5 in front of it, y has a negative 2 in front of it, and they're both on the same side. So that's not really great. The second equation, though, is y equals something. Okay, it's y equals 4x minus 5. So y is already solved for in the second equation. So this is nice. Now, what it means to substitute is, well, if y equals 4x minus 5, what that tells me is I can take that value of y and I can go ahead and put that into the first equation. So why is this helpful? Well, that's because now I can do 5x minus 2, but now instead of writing y in the first equation, let me use what y equals. Y equals 4x minus 5. And that equation is equal to 4. Okay, so I have where one of the variables equals, I put it into the other equation, and so now this is nice because now this is a chapter 1 problem. This equation just has x's in it. So let's solve for x, right? We did this back in chapter 1. We should know how to do this, right? Let's go ahead and distribute the negative 2 first of all. So that would give me 5x minus 2 times 4x is negative 8x. Negative 2 times negative 5 is positive 10. And this is still equal to 4. On the left-hand side here, like terms, 5x minus 8x is going to be negative 3x, right? So negative 3x. And let me subtract the 10 over onto the other side so that I just have x by itself on one side. So I get negative 3x is equal to, and now 4 minus 10 is negative 6. So last step to solve for x, divide everything by negative 3. And Negative 6 divided by negative 3 tells me that x is going to equal 2. Okay? So this is the benefit of substitution. I take two equations with two variables, and I go ahead and turn it into one equation that has just one variable, right? And this is something we know how to solve, okay? However, I am not done yet, right? Because so far I have just what x equals, right? We're finding the point of intersection, which means we need to find two values. We need to know what y equals as well. So now we have to substitute again. Let's take our value of x, and we can go ahead and plug it into what y equals, right? That second equation tells us what y equals. It's 4x minus 5. Well, now I know what x is. X is 2. So let's plug in that value. So y is going to equal, whoops, let me rewrite that. Y is going to equal 4 times 2 minus 5. 4 times 2 is 8. Minus 5 is 3. So y is equal to 3. But again, right, we're finding the point of intersection. And so we're going to write our answer now as an ordered pair, which just means x comma y. So x comma y, that is the point of intersection to the two lines, 2 comma 3. So if I took both of these, solved them for y, graphed them like we did the last 2 days, right? They would intersect at 2 comma 3. Okay? So that's basically substitution. All right? That's basically it. Take one of the equations, solve it for a variable, plug it into the other one, so you can solve for one of the values, right? In this case, we solved for x, then we took this x value, plugged it in here, right? And so now we could solve for y. Okay. Let's do another one. Okay. So on this one, right? Let's take a look at the equations first. I have x by itself here. Well, that's nice. But the 2y is on the same side as that. So I don't have either variable solved for. In the second equation, it's the same thing, right? I don't have either variable solved for in either of these two equations. And so what we have to do first now is we have to pick which variable is the easiest to solve for. And so things you want to look for, variables that don't have a coefficient, or sorry, let me take that back. Variables that have a coefficient of just 1, like this x here in the first equation. I think this is the easiest one to solve for. So let's take this equation, 1x plus 2y equals 11, and now let's solve it for x. And so I would subtract the 2y over. So I would get 1x, I'm just going to go ahead and write x now, equals negative 2y plus 11. Okay? So I took this first equation, I solved it for x, and now I can take this value for x, the negative 2y plus 11, and in the second equation, I can replace the x with that. So that would be 4 times negative 2y plus 11 plus 2y equals 17. Right? The negative 2y plus 11 came from the first equation when we solved for x. And so now I have this brand new equation which only has y's in it. There's only one variable in here, nothing but y's, and so now I can solve this. Just like last time, go ahead and distribute first. We get negative 8y. 4 times 11 is 44, plus 2y equals 17. Negative 8y and 2y are like terms, but before I do that, let's subtract over the 44. And so negative 8y and 2y is going to be negative 6y equals, and now 17 minus 44 is negative 27. Take both sides of this equation, divide by negative 6, and we're going to get that y equals, and so let's see, negative 27 divided by negative 6. If you have your TI calculator with you, go ahead and do that. Math frac, right? 27 and 6 are both divisible by 3, and so that would simplify to 9/2 for my y value. And now I can take this y value and plug it in for what x equals, right? We know that x equals negative 2y plus 11. Well, now I know what y is. Y is 9/2. And so let's go ahead and plug it in here so that we can solve for x. So that's going to be now x equals negative 2 times 9/2 plus 11. That was a really bad one. So this is going to be x equals, so negative 2 times 9/2. Well, the 2 out front will cancel with the 2 in the denominator. So that would give me negative 9 plus 11, which tells me that x is going to equal 2. And so my final answer, I write as an ordered pair. X is 2, y is 9/2. And so that's my final answer. Now, don't forget, you can check, right? You can take your values of x and y, plug them into both equations, and they should work out. Okay, they should work out. All right, so very easy to check. Don't forget to do that tonight on the homework. Okay. And just real quick, this is what most of the problems are going to look like. Okay, they're probably not going to have a variable solved for like in the previous example. All right, so you're going to have to decide which one is the easiest to solve for out of the 4 variables here. Is it going to be an x? Is it going to be a y? Well then, which one from which equation? Okay, now it doesn't matter which one you solve for. I could have solved for the 2y in the second equation and I still would have gotten the same answer. However, it's easier on you if you don't have to do any dividing, right? All I did was move the 2y over to the other side, didn't have to divide anything, so that's a little bit simpler. Okay. All right, let's look at another scenario. Example 2. First thing you'll notice, each equation is already solved for x. Okay, x equals y minus 2, x equals 2y minus 11. And so I can think of this as substitution as well, right? And I can do this either way. X equals y minus 2, let me substitute that value in for the other x. Well, that would tell me that y minus 2 is equal to 2y minus 9, right? Each of these was equal to x, right? Y minus 2 equals x. 2y minus 9 equals x. If they both equal the same thing, that means they have to equal each other. Okay? So this is a really nice substitution problem because everything is already done for you. Now we just have to go ahead and solve this, right? Again, one variable, one equation. We should know how to do this. Okay? I'm going to subtract my y's over. So I have my y's on my same side. So I get negative 2 equals 2y minus y is just y, minus 9. And now let me add the 9 over to each side. Those cancel. Negative 2 plus 9 is 7. And then I just have y on the other side. So that tells me that y is going to be equal to 7. Okay, so this is a pretty nice case to have for substitution, right? We just set our two values equal to each other, pretty quick solve, and now if y is equal to 7, whoops, that's not what I wanted to do. Okay, we're back. If y is equal to 7, right, this is a pretty easy substitution now in for x. And I don't know if I've mentioned this, but you can substitute this value of 7 into either equation now, and you should get the same answer. I'm plugging it into the first equation because it's just y, right? In the second equation, I'd have to multiply by 2. Not that multiplying by 2 is really any difficult, but this one is still easier. So I'm going to plug it into the first equation. Again, I could plug it into the second one. Doesn't make a difference. So let's plug into the first one. So x equals y, which is 7, minus 2, which we know is 5. And so my final answer, as an ordered pair, is 5, 7. Okay. Okay, moving on. So let's talk about some special cases. Okay, we've already talked about how to use substitution in different scenarios. All right, the last thing to look at are some special cases. Okay, because sometimes what's going to happen is that your variables will drop out. So this is the same thing as with regular equations. This is the same thing we did with inequalities, right? When all of our variables cancel, we're going to look to see if we get a true statement or a false statement. Okay, and so if we get a true statement, something like 5 equals 5, that's true. Okay, there's plenty of other true statements you can get, and one of the most common ones is 0 equals 0, right? That's when everything cancels out. Okay, if that's the case, then what this tells us is that instead of having two lines, we actually have the same line. And so we talked about this 2 days ago. When we have the same line, the answer is infinitely many solutions. Okay, and that's because I can take a point that's on I can take any of the points that are on the line. Well, if the two equations give me the same line, that means they share all of the points. Okay, and so there's infinitely many points on a line that I can choose from, so I have infinitely many solutions. Okay, now false statements, this one a little bit more obvious, right? 0 is definitely not equal to negative 7. False statements are no good, and so we get no solutions. Okay, true statements, 5 equals 5, infinitely many solutions. False statements, 0 equals negative 7, definitely no solutions there. Okay, so let's take a look at a couple of cases of these. All right. Example 3. So first equation, very nice. Y equals negative 3x plus 1. I've already got y solved for, right? It's negative 3x plus 1. So let me take this value of y and plug it into the second equation. So this is going to be 6x plus 2 times, replace the y with negative 3x plus 1, and that would equal negative 8. And now we solve for x just like we did on the last two examples. Distribute first, so I get 6x. 2 times negative 3x is negative 6x. 2 times 1 is 2. So I get 2 equals negative 8. And now, SpaghettiOs. 6x minus 6x, those like terms cancel out. That's no good. And so I get 2 equals negative 8. Well, I want to ask you guys a very important question here. Does 2 equal negative 8? Heck no. Put that in the wrong spot. No, this is false. We know that. 2 doesn't equal negative 8, and so we say a big fat case of no solution. Now, hopefully you guys will recall that no solution means the two lines are parallel. That's right. If I took the second equation and solved it for y, it would have the same slope as the first line, negative 3, right? It would have the same slope, but the y-intercept would not be 1, which would mean that the lines don't intersect, right? Parallel lines, they don't intersect. That's why I get this false statement down here, 2 equals negative 8, which gives me a no solution. Okay, so that's our first special case. Let's go ahead and try the. Okay, example 4 here, negative 8x plus 4y equals 4. Definitely don't want to solve stuff from this equation, right? Too busy. I'd have to move the x over, I'd have to divide by 4 to get y by itself, I'd have to move the y's over, then divide by negative 8. Yeah, this is definitely not one I want to look at. However, the second equation already solved for, y equals 2x plus 1. So, let's take that value, plug it in to the first equation, so I get negative 8x plus 4 times 2x plus 1, and that's going to equal 4. So, just like we always do, distribute first so we can solve. So we get negative 8x. 4 and 2x is 8x again. 4 times 1 is 4, and that equals 4. And so let's see what happens here. Like terms again, negative 8x and 8x. Uh-oh, SpaghettiOs. Those cancel. I can't believe I just said that. But anyways, those cancel, right? And so we get 4 equals 4. Well, ask yourself, is that true? Does 4 equal 4? Heck yeah. Right? 4 definitely does equal 4. That's a true statement. So in this case, these actually turn out to be the same line if I were to solve each of them for y, which means I can pick any point off those lines, which means I have infinitely many solutions. Okay. So both of those cases are pretty good. Okay, pretty quick work for both of those cases. All right. So again, false statement, no solution. True statement, infinitely many. All right. Okay, one more thing we're going to take a look at. Let's talk about word problems. And I know some of you guys are groaning right now, okay? But this is definitely something we need to practice, that we need to work with. A lot of word problems on the ACT. And, the math behind them usually isn't difficult. It's just that, people don't want to read. So we're going to practice now so that we're ready for it come March, April, or whenever you're going to take it. Okay? The Barrington Library is having a book sale to raise money for a new literacy program. They decide to sell hardcover books for $5 a piece. Well, that sounds important. Hardcover books, $5 a piece. Paperbacks for $1 a piece. That's a pretty good sale for a paperback. A library patron, fancy word for somebody who's going to buy some stuff, spent $23 and bought a total of 11 books. How many hardcover books did she purchase? Well, that's kind of sexist. It's assuming if you're buying books, you're a woman. I can't buy books, I'm a guy? Huh? Stupid question. Anyways, okay, so there's two pieces of information here that are going to help us out, okay? The first is how many total dollars were spent, right? And this is nice because we know the cost of the books. It's $5 for a hardcover, $1 for a paperback. And so some combination of these two has to add up to $23. The other piece of information we have is that this patron bought 11 books, right? So again, some combination of hardcover and paperbacks has to add up to give us 11 books. Okay? So, let's try to come up with two equations that represent that. Okay? And so we have some hints here that are going to help us out. All right? Let's call H the number of hardcover books bought. And let's call P the number of paperbacks bought. And now let's come up with two equations, okay? The first equation, we can talk about the amount of money spent, right? $23 total. Well, hardcover books cost $5 each. And so if I bought H hardcovers, that means 5 times H is what I spent on those. Paperbacks cost $1 each. So 1 times P, or in other words, just P, is how much we spent on paperbacks. And some combination of those has to add up to $23. Okay? And now the second equation is that total 11 books were purchased. Well, that's hardcovers, that's paperbacks put together. So that is H plus P, and that is going to equal 11. Okay, so our first equation represents the money spent. 5H plus P equals 23. The second equation represents how many books were bought. Hardcovers, paperbacks, 11 books total purchased. Okay, so now let's use substitution to solve this system so we can find how many hardcover books were purchased. So, if I want to know how many hardcover books were purchased, I actually don't want to solve for any of these two H's right here. Okay? Instead, what I'm going to do is I'm going to solve for P. Okay? And I'm going to solve for P in the second equation, which means that I should go ahead and subtract H from each side. So that will give me that P equals negative H plus 11. And now, if I substitute this value into the other equation, I'll get 5H plus negative H plus 11. I'm not putting parentheses around this because there's no coefficient on P, right? It's just a 1. And that has to add up to 23. And so the reason why I solved for P and substituted that in is because now I have an equation with just H in it, right? Which is what I want. I want to know how many hardcover books were bought. And so now I have just H's here, okay? So now let's do some addition, all right? So 5H minus H are like terms. That would give me 4H. Get it? 4H. Yeah, you guys are too young for that. Subtract the 11 on both sides. So I get 23 minus 11 is going to be what? 12? And go ahead and divide by 4, and we get that H is equal to 3. So H is 3. So that means this person ended up buying 3 hardcover books. And so I'm going to go ahead and write my answer here. I'm going to see. Whoops. Nope. Can't erase. And so I'm going to write this at the top here. That means in total, we bought 3 hardcover books. And it's important with word problems to actually answer the question. H is 3 is nice, right? But we should know what that represents. Okay? We bought 3, or she bought 3 hardcover books. okay?